Okay, welcome back. So this is the second part of probability. You'll notice that it is, quite short again and not too different from what we were doing before. Okay, so the next thing we need to look at is what an expected frequency is. So the expected frequency is the number of outcomes that you expect, for an event with a certain probability and a certain number of trials. So an example for this is, if you tossed a coin 46 times, how many tails do you expect? So the first thing we're going to think about is, what is the probability of getting tails? Okay, we know that's a half because there's two options altogether and tails is one of them. And our number of trials is 46. So we find the expected frequency, and most of you just do this in your head and you know it's going to be 23. But the calculation you're actually doing in your head is our expected number of tails is a half, okay, which is the probability, times by the number of trials, which in this case is 46. So a half of 46 is 23. Okay, so that's how many tails we would expect. Obviously, these calculations do become slightly more difficult when the problems are slightly more difficult. So the second one is we're tossing two coins 100 times. So we're tossing both coins together 100 times. How many times out of those 100 would we expect to get one heads and one tails together? So the first thing we need to think about is when you're doing two events or two things in the one event, your probabilities are going to be different, because we know the probability of, we know for one coin you can either get a heads and a tails. Okay, for the second coin you can get another heads and another tails. So if we pair these up together, you can get heads and heads. You can also get heads and tails. We can then get tails and heads. And we can get tails and tails. Okay, so there's actually 4 different combinations that we can get here. Now, obviously the probabilities are different, because when we've got 4 combinations, okay, our probability of getting 2 heads would be a quarter, or 0.25. Okay, our probability of getting heads and tails, and tails and heads, being the same thing, but one of each, is a half, or 0.5. And then probably of getting 2 tails is a quarter, or 0.25. Okay, so how many times out of that 100 do we expect to get one heads, one tails? So probability 1 heads, 1 tails equals a half again. Okay, because that's our probability of getting one of each, times by 100. So we would expect approximately 50 of those. If we were looking at the probability of getting 2 heads, now in this case we've only got a quarter as our probability, or 0.25, and times that by 100. Okay, a quarter of 100 is 25. So that would be the number of times we would expect to get 2 heads. All right, one more example. In a bag of Skittles, we have a 0.25 chance of getting a yellow Skittle. So I'm just going to write these down. So probability yellow equals 0.25. 0.3 of getting a red. So probability red equals 0.3. Probability green equals 0.1. Probability purple equals 0.05. And probability orange equals 0.3. So if there's 200 Skittles in the bag, how many would we expect of each colour? So firstly, for yellow, we would expect 0.25, so a quarter, times by 200. Now, a quarter of 200 is 50, so we would expect 50 yellow. Okay, 0.3 red, so our expected for red is 0.3 times 200. Now this one, we'd expect 60, so we expect 60 red. Green, 0.1 times 200, it's 20. Purple, so our expected number of purple is 0.05, only 5% purple, times by 200. I always think that with Skittles, they give you the most of the worst colours. So that's 10 purple, I really like purple ones, and so I feel like there's never any in the packet. And then orange, we've got 0.3 again, so that's going to be the same as red. So our expected number of orange is 0.3 times 200, which is going to be 60 orange. Now, the last thing we probably want to do is just add all these up just to check that there is 200. So I'm going to use my calculator. So I'm going to do 50 plus 60 plus 20 plus 10 plus 60, and hopefully you can see there. Okay, that's 200. There you go. So that's perfect. It's exactly what we want. Alrighty, last little bit is just looking at sample space diagrams. Again, this is going to be pretty quick, and then we'll do a bit of work after that. Okay. Alright, so a sample space diagram. Now, with maths, you'll find that in maths we generally tend to make up a whole lot of fancy words to describe different ways that we use tables. So when we're talking about a sample space diagram, it's really just a table that shows you all of the outcomes that you can have when you're looking at two things happening in the same probability. So when we were talking about that two coins with the heads and tails before, I'm just going to do it up here, okay? We can represent that as a table to make it nice and easy to find our how many outcomes there are altogether. So imagine this is coin 1 at the top here, and coin 1 you can get a heads or a tails. Coin 2 you can get a heads or a tails. So in our sample space in here, we can have two heads, a heads and a tails and a heads, okay, and two tails. Right, that's showing all of the possible options of things when we're tossing two coins together. Now, I've got an example here. So we've got two fair spinners, so fair meaning not biased, so all the probabilities are the same. We've got two fair spinners are spun. Spinner number 1 has outcomes 2, 3, 4, and 5. Spinner number 2 has outcomes 6, 7, and 8. When they're spun, the two numbers that you get are multiplied together to get a score. So we're going to fill in what all the outcomes are. So for this first one, if we spin a 2 from the first one, and then whatever number we get in the second one, 2 times 6 is 12, 2 times 7 is 14, 2 times 8 is 16, okay? If we spin a 3, we get 18, 21, 24. If we spin 4 for the first one, we can have 24, 28, or 32. And if we spin a 5, we can have 30, 35, or 40. So there's all of our possible outcomes that can happen. Okay. What we want to do is the next part of the question says, B, find the probability of scoring. Firstly, 30. So our probability of getting a score of 30, there is only one outcome where you get 30, which is here, and altogether, there's 12 outcomes that can possibly occur. So our probability of getting 30 is 1 out of 12 altogether. Probability of getting 24, now you'll notice, 24 is a really great number. It's got lots of factors that multiply to make it. So we can have one way of getting a 24 there, and there's a second way of getting a 24. So our probability of getting 24 is 2 out of 12. And we can simplify that down. 2 goes into 12 6 times, into itself once, so our probability is 1 out of 6. Okay. Between 20 and 42. So I'm going to make this a little bit easier on myself because I can see that there's lots of numbers that are between 20 and 42. And there's only a few numbers that are less than 20. So that's the way I'm going to work it out. So I'm going to go with, let me use this colour. And I'm going to count all the ones that are less than 20 instead. So 16 is less than 20, 14, 12, 18. Now there's no numbers that are bigger than 42, so that's fine. So if I know there's 4 that are less than 20, and there's 12 altogether, that means there must be 8, which I can count there. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 that are between 20 and 42. So that's 8 out of 12. Now 4 goes into 8 twice, 4 goes into 12 3 times. So my probability is 2/3. Next one, an even number. Now again, I'm going to do this, I can see that there's less odd numbers in the table. So I'm going to count the number of odd numbers there are. So there's one odd number here, 21. And there's another odd number here, 35. Now they're the only two odd numbers. So if there's only two odd numbers, that must mean there must be 10 even numbers. And again, 2 goes into 10 5 times, 2 goes into 12 6 times, so my probability of an even is 5 out of 6. And then C, explain why it is impossible to score a square number. So why is it impossible to score a square number? It's because there's no doubling up of values, because no two of the same value are in both spinners. Okay, so we can see if we were going to get a square number, if we had a 6 instead of a 5 there, that would be 36, and then we would have a square number. But because you have no two of the same values when you multiply them together, there's no square numbers. Alrighty, so that's it for sample space diagrams, and for what we were doing before that, expected frequency, and actually for probability. So have a go at some of the questions, and then, yeah, we'll take it from there. Okay, alright, have a great day, bye.